Hey guys, this is Shula from shulatutoring.com, and we were working on rate law this week with multiple students. So I figured I will post one more practice problem for you guys to work on over the weekend. So here's the problem. We need to consider the following data. We have four measurements for reactants A and B. Those are concentrations. And then we have initial rate for each concentration. So A plus B equals some products. What products are is not important. And we need to find the overall order for the reaction. And then we need to write rate law for the reaction, including the value of the rate constant K. So how do we determine the overall rate law for this reaction? So this is the formula. The rate is equal to K, which is the proportionality constant, times A to the power of N times B to the power of M. So those square brackets stand for concentration, and N and M are exponents. So overall order of the reaction is N plus M. So let's find that order. So like I was telling you before in class, what we need to do, we need to find some point where one of the reactants is constant and the other reactant changes. So here, this guy is constant, right? It doesn't change. And here we change by a factor of 2, right? We go from 0.1 to 0.2. To find how much something changes, just divide the final measurement by the initial measurement. So 0.2 divided by 0.1 is 2. And then we have to see how the initial rate changes in response to change in concentration of A. So we need to divide 0.103 divided by 0.026, and it equals to 3.96, which is approximately equal to 4, right? We can assume that this is 4. That means that when concentration of A changed by a factor of 2, initial rate changed by a factor of 4. So this is indicative of second order reaction. So far we can write rate is equal to K A to the power of 2, right? If it was first order, then the rate would also change by a factor of 2. So let's take care of B. We need to find that point where A is constant. So this is it, right? A is constant, doesn't change. And B changes by a factor of 2. So what happens to our initial rate? Our initial rate changes by a factor of 2 as well. So this is direct proportionality, and this is first order reaction. So B to the power of 1, we don't have to write it, but I'll write it for now. So overall order for this reaction would be 2 plus 1 would be 3, right? So if the reaction was 0 order with respect to one of the reactants, we would see that as the concentration is changing, the rate is not changing, because for 0 order, the rate is not dependent on the concentration, it is independent of the concentration. So now we need to write rate law. And to write rate law, we basically need to find the K once we found all the exponents. Okay, so to find K, we need to plug in one of the existing concentrations and rates in our equation. So as you notice here, we have 1, 2, 3, and 4 different measurements. So I can pick any one of those to use in my formula. So for example, I can pick the first one, right? So rate is 0.026 is equal to K times 0.1 squared times 0.1, right? So, and all I have to do at this point is solve it. So it doesn't matter which one you pick, right? You can pick the second one, the third one, the fourth one, but you can't pick, let's say, concentrations from the first measurement and rate from the second measurement, right? You can't do that. They have to come from the same one. So let's just solve this real quick. So we get 0.026 is equal to k 0.1 squared times 0.1 is equal to 1 times 10 to the power of -3. And now we just have to divide both sides by that so that we could find our rate constant. So k is equal to what? K is equal to 26. So this is our k, and now we can write rate law. We say rate is equal to 26 times a to the power of 2, a squared, and times b. This is our rate law. We answered the question. So if you have any questions about this problem, please let me know in the comments. If you need practice on something else, like additional practice on some other problem we did this week, please mention that as well. So have a good weekend, and hopefully I will see you next week.